Welcome to the Real Python Podcast. This is episode 43. What's it like to design a Python library for 3 different audiences? This week on the show, we have Nir Aides, creator of Jupylet. His new library is designed for researchers in deep reinforcement learning, musicians interested in live music coding, and kids interested in learning to program. Everything is designed to run inside of a Jupyter Notebook. Nir's initial goal was to create a framework for his own study of deep reinforcement learning, and this led to building a framework for 2D and 3D games and graphics. As he continued the development, he realized that this interactive environment could be useful for learning Python. We also talk about how he got interested in live music coding and the advanced mathematics of sound synthesis. Nir also shares some resources for finding graphical assets and tools for creating 3D models. As a programming note, our connection had some sound issues. We worked hard to try to clean it up for you, but you'll still hear some of those artifacts. This episode is brought to you in part by DigitalOcean's app platform. So let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hi, Nir. Welcome to the program.
Hi. Thank you for inviting me.
Yeah. A couple weeks ago, we had mentioned Jupylet, which I'd been calling Jupylet, and you said you weren't too concerned about the pronunciation, but Jupylet sounds more appropriate. I got so fascinated with the program, and again, you sent me an email, which I mentioned that you had updated the MIDI drivers, and I was having a lot of fun playing with that. Again, thanks for sending me that email.
Yeah,
and then I said, well, why don't you come on the show? And I know you were a little nervous initially. Thanks for coming on.
Great, thank you.
So maybe that I could start off first just talking a little bit about why, or actually maybe when did you start this project?
Well, I started it about 1 year ago.
Okay.
While I was trying to learn reinforcement learning, I was having trouble customizing the game environment I was trying to use for training the machine learning agent.
Maybe we could go into that a little bit. Like, what is deep reinforcement learning? Because that's something that you mentioned early on in the documents, but I'm not familiar with it that well.
Deep reinforcement learning it's like a modern evolution or phase of reinforcement learning in general. Which is a field that goes back all the way to the 50s. It's also a framework that is conceptualizing the way agents interact intelligently with an environment. It can also be applied to biology.
Okay.
There are links between biology and the way it is applied in computer science. You can see it sometimes in articles and papers by DeepMind. They sometimes open their papers by stating their inspiration from biological systems. And I think it's always also in the other direction sometimes. It's also a set of algorithms for developing agents that perform well in this context.
Later in the documentation, you show sort of a DeepMind model learning a video game. I think it was Breakout. Is that kind of the types of things that you were interested in exploring?
That model was kind of a splash moment, aha moment for DeepMind, and it caught the attention of the world. That model it was the first time I think that the model played some of these games at superhuman performance. It's interesting to see from this video how it learns, and you can kind of look at what it's doing and think about it like as if it's an intelligent being. It's very interesting.
I hadn't seen that before, and so it kind of is broken up into sort of stages, like, okay, this is after maybe 200 sort of learning sessions or game sessions, and then there's like, I think it jumps almost every 200 or so. and you could start to see it not only following the ball coming down. If somebody's not familiar with Breakout, the idea that this paddles at the bottom, bouncing a ball up to a set of bricks on the top. And then eventually it starts to learn a strategy, which if you've played the game, that most people want to get, which is to bounce it up onto the top shelf above the bricks. So it's bouncing itself just off the top and removing bricks very quickly, which is always a great moment if you were playing it as a kid to have it. I guess Arkanoid would be a similar like modern version of Breakout. But yeah, I think that's pretty cool. And I didn't realize that was what was happening initially when I looked at it, that this is the computer learning how to play the game and optimize itself.
Yeah, it's fascinating to see it happen. I think I watched this movie, this video dozens of times just for this moment where it's kind of, you see that it's actually playing it at superhuman level. It's like taking a rest while the ball is doing its job on the top of the screen.
Yeah.
It's hard not to think about it as an intelligent being playing the game when it does that.
What are the ways that you've tried to implement that in Jupylet?
Okay, but that was just like the first big moment for DeepMind. I think shortly after that, Google bought them, and they advanced very far ahead since then. I think they're leading the entire domain. Teaching the agents to play such Atari games has been like a basic thing you want to do when you start learning it yourself since then. And that's what I've been trying to do with the game of Pong, which is actually implemented in Jupylet. I was trying to get the model to play it using the classic Atari game simulator.
And so you had to create this, you had to do quite a bit of work to get the game engine built and so forth. And I was looking through the setup.py file just to kind of see like, okay, well, what are the different tools that you're using to create this whole framework, if you will, on top of it? And I noticed that you're using a few different sort of graphic libraries, GL, Modern GL and PyGLM. How are you using those?
These are kind of tools that you want to use as a basis for what you're doing on top of them. Modern GL is a wrapper for the OpenGL API, and which is a very complex, it's a massive API and standard and kind of difficult to wrap your head around. It looks as if it was developed by hardware engineers.
Sure.
Back in the 90s. So, and Modern GL does a very good job of making it accessible to Python. It's very performant. And it also adds some abstractions that make it a little more Pythonic and nice to work with. And it's really a nice project. It's hard to think sometimes of Python and 3D gaming together, and this project really kind of makes it appear possible.
Yeah, that's what I really appreciated that about it. The GL API, one of the advantages is that it itself is cross-platform, right, across multiple operating systems. And so like I was able to run Jupylet on my Mac. And so that's kind of nice that you don't have to build all that. We've been talking about graphical user interfaces, and the advantage to a variety of them is that they do some of the underlying work of making it run on Windows and Linux and Mac. Is that true of Modern GL?
Yeah, it runs on Mac and Linux and Windows. And by the way, there's an amazing developer who's called Nir Aides, and was very helpful. He's always very responsive.
Oh, nice.
And he's got his Discord channel, and all the guys are there and asking questions. And he's always there to help. And without him, I can't imagine all this possible. Really helped out. If any of the listeners is like interested in taking a look at what OpenGL is, Modern GL should be like your go-to project for Python. And also another website which is called Learn OpenGL, which is an amazing resource for learning the OpenGL. It's actually, without it, I find it hard to believe it would have been possible. It got me with the working knowledge quite fast. learn OpenGL and modern GL.
You'll be on your way to building more graphic libraries too. Maybe we should take a step back and talk a little bit more about some of the features of it. I've mentioned it in previous episodes, but maybe somebody's coming to this episode standalone. Jupylet is a multifunction library. You created it for deep reinforcement learning, but you've also kind of created it for a variety of audiences. And so I don't know if you want to speak about that a little bit. You have in your documentation, Jupylet for kids, and then also Jupylet for musicians. It's all the same thing. It's not like you have to install different versions of it, but you have these different sort of focuses in the documentation there. Do you want to talk a little bit about that?
Yeah, because it's, as I said, it started when I was trying to learn reinforcement learning, and I figured that it would make perfect sense to be able to create those game environments directly in Python and interactively in a Jupyter notebook. And so it started, but soon after, it's like kind of a ship that is sailing and changing course.
Yeah,
It occurred to me that it's just a perfect. It might be a perfect environment for kids to learn programming. Just like I had when I was a kid. I had the Commodore 64, which was simply an amazing experience as a kid growing up. I kind of wanted to recreate this experience in Jupyter for kids, because there's a limit to what you can do without graphics. Jupyter is an amazing tool for teaching stuff, but you can show kids how you can use it as a calculator or to make a simple loop that prints strings like their name or hello world. But after a while, it's like you can run out a little bit of what would I show them next? Like the people not too serious. It's kind of you need something to grab their attention, and I figured out that gaming, graphics, and music would be a very good combination together with Jupyter.
Oh, you grabbed me. As a kid at heart, if I would have had something like this early on, this would have definitely excited me. And I was very early on in my programming stages. I didn't think I mentioned this to you earlier. We were talking a little bit offline before about our kind of computer backgrounds, but I had an Apple II sort of clone that was called the Atom. It would basically attach to a ColecoVision game console, and it would let you do basic stuff as far as actual basic programming. I immediately was like, okay, I want to make a surround game, where the dots go around, kind of like, I guess they call it Snake today is a more common name for it. Or I create like two dots sort of fighting again, shooting at each other or something like that. Some simple kind of stuff. I wasn't really, unfortunately, creating any kind of intelligence to it. Most of them were 2-player kind of games because that was the simplest way I could think of doing it. Have 2 people on sides of the keyboard. But I know that if I would have seen more classes and more things that involved some sort of graphical elements, that would have totally pulled me in. So I think that's great.
Yeah, the Commodore 64 was perfect for that, with its graphics and sound functionality, which was pretty advanced for its time.
Yeah. There's people that seek out the sound chip that is part of that. It's called the SID, the SID chip. And they make standalone synthesizers out of it, which I think is pretty amazing. But that is it's like a whole genre of music is chip tunes or whatever they call them.
Yeah, I read about it, but you're actually familiar with such people.
Yeah, I've heard a few different artists that are really, really good create stuff. Maybe I'll include some links. I don't follow them directly, but I think it's really kind of neat what they've created. I think it definitely, the biggest fans are from like kind of the early Nintendo 8-bit, that era of chip tunes. So, but definitely there was some great music created for them. So that kind of leads me into the idea of not only creating graphics, you have this whole other side being useful for musicians. What kind of brought you into that?
Friends sent me a YouTube video about the rare programming languages, and one of them was Sonic Pi.
Okay.
And I saw this video and my mind was blown off. It was simply amazing. It's I forget his name, the name of the developer, but it's really amazing what he did kind of, maybe, I don't know if he created the concept of live music coding. Maybe he did. It was fascinating to see how you can create very sophisticated music by interactively programming the sound as you go along with what he calls live loops, live music loops. And I saw that. It occurred to me that Jupyter is practically perfect for this kind of style of programming sound. And actually, I already had this kind of live loops for programming graphics. So it was like, it fitted like a glove to the Jupyter. And I was actually puzzled why it doesn't exist for Python.
I think there's some, there's a few different languages and tools that are out there that try to do this. I'm blanking on the names too right now. I'll look them up. But the idea of, I think you're right that the thing that ties that all together, especially with this project, and one of the things that's really great about Jupyter Notebooks is the idea that you can execute code kind of as you go. You have all these cells, right? And so the idea that if you wanted to, okay, I guess in the case of the graphical engine, if we go back to that, you do have to create an initial sort of event loop. Would that be what it would be called to get things started?
Yeah, actually, that event loop already exists for Jupyter. Jupyter is under the hood. It's an asynchronous mechanism that connects the Python kernel with the front-end interface. So the loop is already there.
Nice. So you can then, on top of that, build a window and then put things, think of it like a stage or something like that, of adding a graphical element here. In your case, you have a planet and then like a spaceship and some other kind of things that you're adding in some of the initial tutorials. And you can kind of just build them up cell by cell.
Yeah, right. And you can manipulate them as the game is running.
So behind the scenes, if you wanted to do something that might be considered a little more advanced, like add collision detection, is that something that as it's moving along, is that hard for you to program and add inside of Jupyter's event loop?
There's already a collision detector for the 2D sprite.
Okay.
Pixel accurate. It's not. It was not designed to be very efficient, but it's working. When it comes to async programming, you kind of need to be careful about the budget of computation that you're using, because if you're unfriendly, then nothing else can happen in parallel. You need to keep the computations short and relinquish control, so other stuff can keep happening.
So what are the mechanisms that you can use to help you keep the async stuff kind of clean and performant?
Usually, in most cases, if you're not doing something exceptional, Python is fast enough for most things, so you don't have to take care of it or to worry about it. But if it comes to that, then it's kind of a little bit of experience. You need to be careful about what you're doing. There are usually a few different ways to program something. So the naive ones are maybe too time consuming or CPU intensive, and sometimes a little bit of tweaks can make things go a lot faster. But for most things, you simply don't have to worry about it.
That's good. If somebody were to have a loop that's suddenly, not behaving well or something like that, with the Jupyter Notebook, it's fairly easy to just sort of restart all of it. Is that correct?
I think that Jupyter, when you ask it to interrupt the notebook, it will simply, it's like hitting break with the keyboard. It will just stop, so you can try to figure out what happened.
Yeah. So kind of building on top of that, had you been using Jupyter Notebooks in your work a lot before you started doing the project?
We've been using them for about three years. Pretty fast, I got addicted to its interactivity, and I could never go back to anything else now.
Okay. So the interactivity part is the fun part for you.
Yeah, it's kind of amazing. When I was looking for, occasionally I tried to make my two daughters curious about programming, and at some point I started looking for game programming libraries for them.
Yeah.
But they are all they're designed to be used classically, like as if you're writing the game in an editor, and then you run the program to see what happens.
Right.
And if it goes wrong, you go to the editor and try to figure out and fix it, and then you try to run it again. Jupyter, you can do all that on the fly, which is, for me, it's like amazing. It's like if you think of it like a kid that is trying to build an airplane model, and from paper or wood, may take 15 minutes or a few days, and then he goes to the top of the hill and try to throw it. It flies a little bit, and then it spins and crashes. So you got to fetch the plane and go back and fix it and try to modify it. And with Jupyter, it's like you're fixing the plane as while it's flying in the air. Like you're sitting in the plane and it starts to spin. So you say, well, I'll try to fix it now. I'll modify the wing and see what happens.
Yeah, that's good. That interactivity, we were talking before about music programs, and I had mentioned Apple's Logic platform, and early on they were from a company called eMagic, and they basically, bought the entire company. But one of the things I really loved about that software platform in general as a musician was I could edit almost everything while it was playing. Again, to not have to stop to go like adjust a single note or to change the length of a section of something. It could be playing, or it could be looping, or it could be what have you. And I could interact with all of that and very easily modify things. And in fact, kind of crazily, it had this feature that I always loved where you could be doing something in MIDI and playing along with something, but not actually in recording mode. And it would remember in a buffer everything that you had just played. So you could say, oh, I wish I was recording right there. And you could actually hit a key and it would grab everything you had just played and actually put it in. So nice. That kind of like nervousness that some people have of always hitting record and so forth, you could just be kind of fooling around, if you will, and bring it back in. And so that kind of creative play, I agree. I think that's incredible. And Jupyter Notebooks will be really useful there. I have a question on that as far as interactivity. One of the things that Jupyter can allow in certain circumstances is sort of like cloud kind of stuff. And I don't know if like having more than one person interacting with the code, is that possible with Jupylet?
I don't know that multiple people can use the same notebook in the same simultaneously.
Okay.
Is that possible?
I don't know. I'm trying to learn more about that. I had a couple teachers on. They have a program called Teaching Python, and they have kind of moved to using more notebooks. I think Google Colab and a couple other kind of places where, they've had this year, right? With COVID and all the stuff that's involved with that, they've had to do a lot more remote teaching. And so the ability to at least share the resource, almost like turning in your homework and being able to kind of show it and so forth. But also there's like the undo history that's sort of built into notebooks also. Yeah. That's been helpful for them with teaching students and being able to fix potential mistakes that they may have. Like, it's like, oh, let's go back, kind of like a primitive, version of Git or what have you to help them kind of go along. But I was just kind of wondering about that, if you wanted to have interaction with more than one person.
I haven't thought about it. Maybe and even if it's not implemented in Jupyter now, it should be technically possible in the future.
Yeah. All right. This episode is brought to you by DigitalOcean's App Platform. DigitalOcean's App Platform is a new platform-as-a-service solution to build modern cloud-native apps. With App Platform, you can build, deploy, and scale apps and static websites quickly and easily. Simply point your GitHub repository and let App Platform do all the heavy lifting related to infrastructure. Get started on DigitalOcean's App Platform for free at do.co/realpython. That's do.co/realpython. When you started to work on the project, what were the features that you were most interested in including?
When I started, it was about making it possible to create simple 2D games interactively in the notebook and to be able to run them effectively and efficiently for machine learning. It's like it was important that it should be possible to render like thousands of frames per second for the model to train. It was important for me to be able to customize the environment easily. That was the main points as I was starting.
Along with that, like what were features that you felt you really had to include?
I don't really understand.
I guess the question would be, as you sort of expanded the scope of it and thought about it being potential for kids to be able to use it and sort of expanding a little bit of the scope beyond it being only for the reinforcement learning, what were things that, as you started to change that focus, where you said, okay, maybe this would be really great for teaching Python or teaching Jupyter Notebooks and so forth. What were some of the features that you felt like, I need to include this. This is something that is going to be really important if I'm going to say this is for kids also?
Yeah, so for kids, it was important to try to keep it simple conceptually.
Okay.
And also sometimes in terms of how you name things, like I think that in many environments, when you want a function to run periodically, you might call the function that sets that up, you might call it's probably called schedule to run multiple times. But I was trying to think, how will kids spell the word schedule? It's like hellish.
Yeah.
And so I called it run me or run me many. The decorator, so you write a function and you want it to run multiple times, so you decorate it with the decorator that's called run me many. Then you specify how often you would like it to run, or run me every, I think. Or run it. It's like an association from Alice in Wonderland when she sees the bottle written that's written all over it, eat me.
Right. I think that's pretty crucial. I mean, you're using some advanced Python features in here, the idea of decorators. And I definitely got introduced into that pretty early on. I've talked about that on the podcast a couple of times, that was some of the parts of the language where it just kind of looks different. It looks kind of foreign, and you don't completely understand what it's doing and kind of underneath there. But
right,
it provides such crucial functionality for you be able to, in this way, to tie these different events and functions together. But I agree with the naming process that if you can rename the methods and the functions that make people want to play with them, and they're not like, well, that is just confusing, the wording. You have kind of a similar thing with sprites. You're building the graphics and using the terms there.
Yeah, so for example, in the sprites, actually I was inspired by a project called Pygame Zero. I was looking for a framework for my daughters, so maybe I will be able to make them interested in programming. And Pygame Zero seemed very interesting, and the terminology like distance to the method. When you have a sprite object, it has a method like distance to, and you can put another sprite object as an argument, and it will tell you the distance. So some of these methods are inspired by that framework. Another aspect of keeping it simple is to use functions instead of forcing kids to understand classes,
okay,
which I think are more complicated conceptually. Maybe also the documentation, I try to make it more accessible.
Yeah, no, I noticed that. Do you have other people helping you with the project as far as the documentation, or is it mostly a solo project?
In terms of documentation, no, but some people advise me from time to time. They tell me their opinion, or my nephew is a mathematician, so I had a problem with when I started fountain playlist. I had a problem, and it's an interesting problem with the sawtooth waves. That the ideal, if you think about the sawtooth wave, the way it looks like a little saw, if you actually try to play the ideal wave, it emits unpleasant buzzing sounds.
Okay.
Are you familiar
what kind
with
of wave? I heard DL. Is that right?
The sawtooth.
Oh,
wave.
sawtooth. Okay, yeah.
So if you think about the ideal way it looks like, if you try to play that one, it will emit unpleasant sounds. If you try,
this is pretty nasty sounding. Yeah.
I don't mean like specifically the sound of the wave itself, but there are accompanying buzzing sound that you might hear if you try to play the high frequency.
Oh, would they be like artifacts that are being created that are not intended of the pure wave itself? They're just kind of getting generated by the process.
Right.
Okay.
So my nephew, who is also a musician, immediately had pointed me in the right direction. It's called it's problem of aliasing, aliased sound wave.
Yeah.
What happens is that you cannot actually play the ideal waveform. You got to only play the harmonics that compose it up to the so-called Nyquist frequency. So if you look at the documentation of the sound synthesis chapter, you can see the sound wave with a little bit of waviness on top of it.
Okay, yeah.
This is because it is made of a finite sequence of harmonics. And when you play that one, it sounds nice. So this is kind of advice I sometimes get from people.
That's great. Yeah, that's something I used to teach, digital audio. That definitely would be a limitation for most sound cards and what the digital audio system can reproduce. When you're creating this pure wave, it should be able to have all the harmonics and frequency, all the way up in human hearing, but it's not an analog system. Unfortunately, there's a set of samples. And I think, I'm not sure, but I would guess is it running at 48 kilohertz or 44.1 or
44.
Okay. So the Nyquist frequency is this idea of kind of dividing that in half, and that is what typically could be, I won't say accurately, but what frequencies can be represented. And then if you kind of go above that, it has this whole weird folding artifact, really strange sounds that you end up hearing. They sound a bit like the artifacts that you hear on a really bad voice over IP call. Yeah. So you have to, a lot of the systems, on a CD, so forth, they would have these anti-aliasing filters and other tools to kind of remove that. So you're having to plan and program ahead all that stuff. That's I can imagine that's pretty intense. Just you're like, well, we'll do synthesis with this. This will be simple, and then you
That's what makes it fascinating. I like mathematics, and I enjoy the way mathematics comes to life in sound and in graphics. This is what makes it fascinating.
Yeah, cool. So that's it's been a bit of your introduction, not really being, like we talked earlier a little bit about, I had asked you if you were a musician, but this is kind of an interesting way into that, the whole sound production and that's one of the things I think why I enjoyed music and math, and kind of the combination of them is they're very, very much related.
Right.
And so you're kind of going on back into that a little bit about the synthesis side of things. You're doing a lot of the math using either pure Python, but you're also in some cases using NumPy. How's that come into play?
I use NumPy massively for that purpose. NumPy it's a very basic library for data science in Python, and it's very efficient for manipulating arrays of numbers, tensors. I used it for doing all the computation, all the sound processing, because pure Python is just too slow for that. If you really want to do it efficiently, you have no choice but to use such a library. That's the natural way to go, because sound processing is a form of computational graph. This is what sent me with my this is what inspired me to use the way PyTorch is designed to build deep learning models.
Okay.
So this is what inspired me. It's actually suddenly occurred to me that there isn't much difference between the computational graphs in deep learning and the computational graph you build when you actually assemble a sound synthesizer from all kinds of components that are each applied to one another and until you get the sound you want. This is also a computational graph, so it sounded natural to try to apply the tools and the conceptualization, the concepts from PyTorch to sound synthesis. It was fascinating to see how it comes together really nicely.
Yeah, like the synthesis part is, like, I haven't even had a chance to dive super deep into it, but the idea of like not only starting with like the fundamental waves, like you were talking about sawtooth and, you know, square or sine or what have you, which are just, you know, great as far as like, again, practicing math and so forth, as far as, you know, a form of human reinforcement learning, a way to kind of practice these things. But then you kind of get into not only that, the true other parts of synthesis of filtering. You have a whole, you know, setup for the synthesizer with the attack, decay, sustain, and release, the ADSR envelopes.
Right.
Even some of the effects, like sound effects of like reverb and modulation and overdrive, which is really cool. And again, those are things that I've wanted to play with inside of Python too, which I'm fawning over your project. So but it's very cool. Like it sounds like how long have you spent just even on the synthesizer part of building this?
Took a few months, but it was great fun. You mentioned the reverb effect, and I had to learn about it to do it. And there's a basic reverb effect called shredder reverb. Okay. Maybe you know.
So those are algorithmic reverbs versus ones that are trying to, the one that you mentioned below that, and
the impulse reverb.
Yeah. That was new when I was teaching digital audio at the school I worked at about 15, 20 years ago. The idea of setting off an impulse in a space and then recording all the reflections to sort of be able to recreate that physical space, like a small, you know, everything from like a tiled bathroom to a hall, you know, a big room like that. So the
Shredder.
What's going on with that?
This is, as you said, this is an algorithmic reverb, and it was described about 60 years ago by Armand, I think. Schroeder was a physicist. He constructed it. I suppose it was an electronic device made of many components and types of filters that he used, but he described it mathematically. And it was very interesting to implement it. Since it was described mathematically, it was possible to try to recreate it with NumPy and in a computational graph. And it worked just perfectly out of the box. It's fascinating.
That's cool.
Fascinating to see how mathematics that was used to describe an electronic device, theoretically, comes to life like 60 years later.
Are there parameters inside of that you can control for the, you know, things like reverb has like usually a decay, like in milliseconds or something like that, or early reflections, and are those types of parameters that are part of that?
Right, and his particular design contains a lot of such parameters, many such parameters that you need to set.
Okay.
And it's considered sensitive to these parameters. And I simply used the ones that he recommended 60 years ago, and it just worked perfectly.
That's great. And then convolution, I'm guessing that's a whole other version of math where you end up having to have those impulses to build things from, right?
Right. If you're doing convolution, then NumPy and also SciPy, which is a related project, related library, they contain many of these functions right there for you, including filtering.
Oh, nice.
Digital filtering. They already have this in them.
This week, I want to shine a spotlight on another Real Python video course. It covers the underlying tool that we discussed this week. It's titled Using Jupyter Notebooks. The course is based on a Real Python article by previous guest Mike Driscoll. And in the course, another previous guest, Martin Royce, is your instructor, and he takes you through installing Jupyter Notebooks on your system, creating new notebooks, adding rich content, exporting notebooks in multiple formats, and adding more functionality with notebook extensions. I think it's a worthy investment of your time to learn how to work with, manage, and share Jupyter Notebooks. These notebooks are used everywhere and are useful not only for learning and teaching Python, but also for sharing your work and data with others. And like most of the video courses on Real Python, the course is broken into easily consumable sections with a transcript and closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the search tool on realpython.com. A couple quick things I guess we could kind of dive into here. When you're working on a big project like this and you're using all of these sort of underlying libraries, things like modern GL, I didn't mention it, but you have like a MIDI library that you're using NumPy and so forth. How difficult is it for you as you're creating a project like this to manage and make sure that as you're updating your code, that dependencies underneath it aren't breaking things inside of what you're creating? Is that something that you have to fight often, or things that you have to think about in the process of building a library like this?
Jupyter installs many libraries, but most of the dependencies are related to NumPy. Not NumPy, sorry, to Jupyter.
Okay.
So, and Jupyter doesn't use them directly. But that said, the only problem that's happened so far, the only case where a library broke Jupyter was surprisingly a bug related to NumPy.
Okay.
Actually, two different bugs. One on Windows and another problem on Mac machines. And it's surprising because NumPy is a massive library that is used by millions of people. And this library, which is very well tested, actually was the one that broke not just me. It broke developers probably all over the world.
Yeah.
So on Windows, there's a specific version of Windows. I think actually the most updated version of Windows currently doesn't run the latest version of NumPy. It's kind of amazing, but that's the way it is. And on Mac machines, there's another problem related to parallelization that you need to work around. But that was the only problem so far.
That's good. Yeah, I can imagine. And I guess that NumPy, I'm sure, is a pretty complex project because of all the underlying, I guess, C code that's involved in making sure it compiles properly on all those platforms as they progress.
Right.
Okay. As we were talking earlier, we also talked a little bit about the need for assets, the things that you would use. In this case, you have a variety of them. We go back to the game programming stuff. Do you have some suggestions or resources that you think are useful for finding different graphic assets?
The one you mentioned, Ken, is an amazing website with a lot of good stuff. And for 3D, you basically need textures and sometimes even models.
Okay.
And there's a series of websites for textures, physically best rendering textures.
Okay.
It's called Texture Haven.
Okay. Great.
And you can find textures over there and models and HDR.
Oh, wow.
It's very, very, very good resources. And there are also other, the internet is full with resources. It depends on what you want to do. Because, for example, for Jupylet, I wanted to include only such assets that where I could include them legally. So it took a while to find these websites.
Yeah, that's always a challenge, huh? Finding things that allow for some kind of open license.
But if you're using it for creating personal stuff, then you probably have a lot more options on the internet.
That's true.
The moon, by the way, the texture of the moon is directly from NASA.
Oh, cool.
It's an accurate texture for the moon, also for its normal. It's called the normal map. It's the one that creates the effects of shadow on the line where day becomes night.
Yeah. Wow, cool. So that's going back a little bit to talk about the 3D part of it. We didn't really dive much into it. The graphic engine that you're using here can create games that are 2D, but you can also have three-dimensional, not only assets inside of it. So then you have to think about the idea of like, okay, you have the geometry of this 3D thing, and then you're wrapping textures around that. And those are things that you create inside of, do you do that wrapping inside of Jupyter, or do you do it in like a separate tool and then import the whole thing in?
Right. You can conceivably do it programmatically, but just as you wouldn't try to, inside Jupyter, you wouldn't try to paint a sprite,
Right.
you would use a third-party image painting program. For you use the same kind of tools for 3D programming. So
Okay.
what the project that I love, it's an amazing project. It's called Blender. It exists for many years, but it really took off like in the recent several years. It really became a lot more usable and polished. And it's an amazing creation suite for creating 3D. So you actually model a scene in Blender, and then you export it to Jupylet. So Jupylet was designed to import Blender scenes seamlessly.
So a scene, would that have multiple components, like multiple, I don't know what to call them, assets? It could be like a background, and then the planet and like a spaceship, and all the separate different pieces can be described in a single scene.
Right. You need to model the objects like the moon and the alien, and then you wrap them with the texture. You place the cameras and the light sources.
Oh wow! Okay. Yeah.
You do all that in Blender, and then you can export it. And actually, the export files, the Blender files, the original Blender files, are included in the examples directory. You can find them there.
Okay. When you have a scene like that, are all those individual objects that are part of the scene, like the camera or the lights, are they accessible from Jupyter to be able to animate?
Right. When you import such a scene into Jupyter, you can access all these objects. All these objects become Pythonic objects that you can manipulate. Like you can find the alien object in the scene, and you can double it, scale up its size, or change its color. Or that's the way. If you look at the example spaceship 3D notebook, you can see how these objects are manipulated.
Wow. This is like such a great tool to like, if you really want to, not only to learn just like programming, but also like game design in some ways, the hard concepts of them, now you're gonna have to worry about sort of Z space and objects on top of other objects, and to be able to kind of manipulate them in real time. I think that's really amazing.
Right.
Yeah, cool. So how's the feedback been? What's your feedback on the whole project been like?
It's really just starting, because the release of the way it looks now, it's a release from last month, like 1 month ago.
Okay.
It was the first time it really came together as a project with the documentation and sound synthesis and 3D graphics. And so it's really very early, just 1 month. So far, the feedback was mostly in the form of stars and GitHub.
Okay. Yeah.
But I have patience. I'm in no hurry.
Okay. Are you looking for contributors, or how could somebody help with the project?
Well, first, if someone is interested in contributing, they're welcome to contact me and start to communicate about ideas. There's also a page, my email is in the project page, and there's also a new feature of GitHub for discussions.
Okay.
I guess if someone wants to contribute, this is someone who has been using the project and is kind of needs some functionality that is missing and would like to see included. So it's a good basis to try to contribute something. Another way would be to maybe help document the code. It's maybe a good way to get to know it.
Yeah. I was thinking about people helping to provide additional notebook examples would be potentially another.
That would be amazing. Okay. Yeah.
That's like, for somebody at my level, like I feel like I could I could try to do something along those lines, which I think would be fun.
It would be amazing. Since you're a musician, if you contribute such a notebook, wow, that would be great.
Let me see what I can do. We didn't even really focus on it, but we talked a little bit about the live programming part of it with the music part. But the idea is that you can kind of, again, create musical loops that then can kind of build on top of each other so that you can, say, create like a drum beat or something like that, and then add like a bass line and add all these kinds of things, and then be able to start and stop them. How's that project or part of the project been going?
Kind of like the state of the entire project. It's trying to do a lot of stuff.
Yeah.
And in every area, it's like just the beginning. There's a lot of room to make it, to evolve it, and to make it grow and make it better. And the same is with the music, with the live loops. It's at the moment, it's kind of basic functionality, and you can already do stuff with it. But there's a lot of room for new functionality.
I had Wukas Longa on early on in the podcast, and we were talking about async IO and music, and he was using async IO to teach, or basically using music to teach async IO. He kind of created a live sequencer in just code, and he's using the same MIDI library that you were using underneath the scenes. And he was, in this case, not doing the synthesis internally, inside of like the code. He was just having, in this case, sending MIDI notes in and out. And we were talking about, some of the advantages of MIDI, being small, like little tiny of events and stuff. And so we went into a deep dive. That's why I was thinking about the idea of, he was hoping to go to PyCon last year and, demo some of this in a live sort of fashion, that somebody could interact with the code and while it's playing. And so I don't know, I think there's maybe some synchronicity there. I'll have to flag Wukas on this and see if he's interested in checking it out.
He was also programming this for Jupyter.
No, it was just standalone. He was using a different async IO loop, a UV loop, and it was just more kind of a way. It was a talk, like a PyCon presentation talk. He works for a database company, and he was trying to teach a little bit about async IO, and he felt like music would be a good way to kind of show off.
Sure.
Very often async IO, unfortunately, is taught in a way where people kind of create fictitious types of things, like, I'll just put like wait states in here, and it doesn't feel like an actual, like, something that feels like would really happen in the wild, if you will. And the idea of a sequencer where it really does have to await and play on a beat or play on a particular moment, I was like, that's, such a perfect way of kind of explaining the idea. That's why I really wanted to talk to him about it.
If you put a link, I will check it out, definitely.
Yeah, I'll share that stuff with you.
Async IO, but is I would say it's an advanced topic.
Oh, yeah.
It's not something that it's easy to grasp.
Yeah, I know. And that's one of the things I always found it kind of like challenging to just even to explain some of the concepts behind it. And then, then it kind of gets into the implementation details that are also kind of a little hard. Did I miss anything? Or were there certain things that you wanted to discuss a little bit more about the project?
Well, I can go on forever talking about
it. I totally understand. I have a couple of weekly questions. The first one is, what's something that you're excited about in the world of Python? That could be a package, an editor, a book, or an event that's coming up. Something that you're excited about that's happening.
Well, in Python, what's exciting me is its impact on deep learning.
Yeah.
Deep learning is, in my view, like it's a revolutionary moment in the history of humanity. It's like we cannot really anticipate how humanity will be like 50 years from now because of the consequences of what is happening now, how it would affect society. For example, if in terms of work, of jobs, if machines will be able to do so much of what people are needed for now, how will society will look 50 years from now? And this is why I believe it's kind of a revolutionary moment in history, and Python somehow got into position of having impact about it because of its role in data science, and because it's so easy to use it to express ideas and to develop. Specifically in deep learning, there's a library that I like to use. it's my go-to, it's my favorite. It's called PyTorch. And I believe, in my view, it's the most Pythonic reincarnation of, the most Pythonic attempt at doing deep learning in Python. There are many frameworks, but nothing comes close to being so Pythonic and so makes it so easy for you to express your ideas and create stuff.
Are there any resources that you suggest if someone wanted to learn more about PyTorch?
Simply Google it, and they have in my mind, they have a very good documentation.
Okay.
Deep learning is really growing extremely fast. Moving, it's like, if you try to learn it, it's like trying to learn a moving target. So
yeah,
the documentation from 2 or 3 years ago might be already outdated. So it's kind of hard to recommend.
Go to the source. Yeah. Out of all the things that you're interested in here, what's something that you want to learn next?
Reinforcement learning.
More about it.
I was actually kind of sidetracked because of Jupylet, and it was very exciting to create it. Now I have to use it to actually for its original purpose.
What are other types of games that you would want to create in your platform? You've made a Pong one. Are there other ones that you have as goals in steps that you're moving toward setting up in your deep reinforcement learning?
Maybe, yeah. There are many interesting papers, for example, by DeepMind, also OpenAI, where they describe agents interacting with the 3D environment. They've been using more and more. They've been using Unity to do that.
Yeah, I think we heard about a soccer, football simulation. I don't know what platform that was on, where you would sort of try to compete and program parameters to see how well they would perform. It was like sort of a bit of a cup, like a challenge. So right. I don't know if that's one that you've heard of.
Yeah, but the idea is that it would be nice if it would be possible to create also 3D environments and with Jupyter.
Yeah.
Specifically, I was thinking about trying to recreate an agent that interacts, try to figure out a maze in a 3D environment. It would be nice if it could be done easily, or if Jupyter would develop in such a way that it would be easy to create such environments in pure Python. And tools such as Blender, which is it's an amazing tool.
And you could create a whole maze type of structure inside of Blender?
Yeah.
I was just thinking about that.
But the idea when you're trying to teach an agent to navigate a maze or accomplish some task or solve some problem is that you need to create this maze programmatically. It should be different maze each time. So
yeah. Okay, so that it would... that's interesting. So with the textures and the geometry, you could set up some parameters that it could randomly generate them.
Right. You would create the basic setup in Blender, and then it should be possible for Jupyter to use the building blocks like walls and stuff to create the maze dynamically.
In the 2D implementation that's there now, is there the ability to create something like maps?
At the moment, no. These are stuff that...
Advanced, yeah.
It's not that they're advanced, it's, the saying, sometimes you hear your information will be supplied as on a need-to-know basis. So this is features come that should get in as someone needs them.
Yeah. That's cool. I mean, it's additional features that have to be created and implemented, but that, I think it's amazing that you're building on top of just the GL libraries themselves, and not having to structure everything, on top of an existing library. I think in some ways it may have been difficult to take something like Pygame 0 and try to sort of push it into a Jupyter notebook. So I don't know if that's something you attempted to do at any point.
It's nice sometimes to try to build something from scratch, a fresh start, a fresh look at the problem.
Yeah, that makes sense. Well, I really appreciate you taking all this time to talk to me, and I love the project. I'll see what I can do as far as contributing to it, because I want to see it keep going, and I'll try to share it with my educational people, and obviously share it with the entire Real Python podcast audience.
If there's one really significant, I think, direction for Jupylet is emotionally for me, it's this direction of if it would become effective or usable or useful for teaching kids or teaching programming.
Yeah, I think so. I think it would be fantastic for that. And we've covered a variety of other types of things that, kind of get people interested in these topics. And so I think that even creating some resources like that would fall under the getting kids into programming part would be really, really fun. Anything that adds more, graphics, and I think the interactive part, I think would be super fascinating to them too. The idea that they can change the code as they go, starting and stopping things and adding things.
Feels to me as if there's still not enough awareness how well Jupyter fits for this.
Yeah. We'll try to wake them up, make more people aware. Thanks again for coming on the show and talking to me.
Thank you for inviting me.
Don't forget, you can get started on DigitalOcean's app platform for free at do.co/realpython. I want to thank Nir Aides for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure you subscribe to the podcast in your favorite player. And if you like the show, leave us a 5-star rating and a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.